All right, welcome to this edition of Comet Algebra. This is the Algebra 2, Chapter 1, Section 1, Real Numbers edition. I know we're going to have lots of quality time together on this Comet Algebra channel. These lessons are available to you all year so that you can use these when you need them if you're stuck, like on a weekend. Well, except if it's Sunday afternoon and the Vikings are playing, then I could understand why, you just wouldn't want to spend time on this channel. But other than that, it's always here for you. So I hope you have your summer packet in front of you. We're looking at section 1.1. And the first thing I'd like you to add to the notes that you were given is these symbols that our book uses, and we need to be familiar with them. So the real numbers, which of course is represented by the entire box there, the whole rectangle shape, are the real numbers. That's that funny looking R. The rational numbers is the section on the left with the circles inside it. Rational numbers are all numbers like decimals that actually do repeat or do come to an end sometime. The right side of the rectangle are the irrational numbers, and the symbol you can put there is this funny looking Q with a prime symbol. Irrational numbers are the goofy ones. They never end and they never repeat. Integers are all the positive, all the negatives, and zero, but no fractions, no decimals. They are represented by that funny looking Z. Whole numbers start with 0 and go in the positive direction. Natural numbers do not include 0. So as you get, those are the circles as you get smaller. So please put those symbols in that diagram and know what the symbols stand for. Let's look at a couple examples. You're asked to state the most specific subset of the real numbers to which each number belongs. So I have a couple examples here. First of all, -5. -5 is obviously a real number. It is also a rational number, and even smaller than that, it belongs to the set of integers. So I would label that with that funny looking Z. My second example here is -1/3, certainly a real number, but even smaller than that, it's a rational, but it cannot go down to integers because it is a fraction. So we're going to label this one with the funny looking Q, stating that it's rational. My example 3 here is square root 2/3. Square root of 2, interesting number. If you punch it on your calculator and you look at it, it displays as far as the calculator is possible to do, but then it does not repeat, it does not have a pattern. In fact, it never ends. So any square root that is not a perfect square is indeed irrational. And it doesn't matter if you divide an irrational number by 3 or any rational number, that doesn't change it. It is still irrational. So we're going to label this one with the Q prime. So now you have the knowledge you need to do 1 to 8. The next definition we need to talk about is closed. When a set is closed, it means you can do whatever the operation is that you're given, and your answers will stay a member of that set. So, for instance, my example here, number 4, are the whole numbers closed under subtraction? In other words, if you take any two whole numbers and you subtract them, is the answer you get still inside the set of whole numbers? And in this case, I would have to say no. Whole numbers are not closed under subtraction. And when you say no, you have to give a counterexample. In other words, show why it's not the case. If I take a whole number, for instance, of 1, and I subtract 5 from it, I end up with a -4, and that certainly is not a whole number. Next example, number 5, are the rational numbers closed under subtraction? Well, any two rational numbers you can use, whether it's a fraction or a decimal or anything, and you subtract them, you will always get another rational number. So we would say yes. So now you have the knowledge you need to do 9 to 12. Now I'm going to do a quick review of something that is not on your summer packet, but you're going to be responsible for it, and it's something you already know. The properties. The commutative property is the property that talks about order. In other words, 4 plus 7 is the same as 7 plus 4, and multiplication is also commutative. Associative is the grouping property, which says that if you take 2 plus 3 first and then add 8, that's the same thing as if we regrouped it and we added the 3 and the 8 together first and then added the 2. The identity property. This is something that's going to come up a lot throughout the year. We'll talk about an identity matrix, for instance, when we get to the chapter on matrices. What you need to know about identity is that it basically doesn't change the original. If you start with 12 and you add nothing, you still have 12. You haven't changed the identity of the 12. Therefore, 0 is the additive identity. If you start with the negative number, -4, and you multiply it by 1, you still have -4. So 1 is the multiplying identity. So identity just doesn't change things. Next property we're going to talk about is the inverse property. We can discuss additive inverse. For example, 3 has an additive inverse of -3, so that when you add them you get 0. And 7 has a multiplying inverse of 1 over 7, so that when you multiply them you get 1. Now, distribution. This is vital that you remember this. Have to. Distribution involves two operations. For instance, if you had 3 times a plus b, in distribution, we take the 3 and we distribute it to both terms in the parentheses to get 3a plus 3b. Don't ever let me see you write that this equals 3a plus b. I will have a fit and yell at you, and it won't be pretty. Okay, this last part for these examples 6 through 10, could you just hit pause on the video for a moment, take a minute, and identify the property that's illustrated with each of these. All right, now that you have written down your thoughts on what these properties are, let's go through them together. This is distribution, and it is sort of backwards. Because it doesn't matter if the x is in the front or the back, we can still distribute it to both things in the parentheses. This next one, all we changed was the order of the 8 and the 5. Therefore, this is the commutative property. Here, when we're multiplying 3 times 1/3, we get 1. So this is the multiplying inverse. I just lost the ability to spell multiplying. There we go. The multiply inverse property. Here, if we have a value, we add 1 to it. We have not changed it. This is the additive identity. Okay. And on this last one, I sure hope you recognize it. It should be very familiar from your Algebra 1. We had the 3x times the parentheses, so we did indeed distribute it to both of them, and this is the distributive property, which I can't spell and whatever. All right, congratulations. You have finished your first video for Algebra 2 of Comet Algebra. Have fun with that page in the summer packet.